Hello everyone. In this video, let's talk about the segment addition postulate. So this is a postulate in geometry that allows us to combine segments together. So on the screen, I have the postulate written out. It says if B is between A and C, so right away, if a point is between two other ones, we know that they all lie on the same line, then AB plus BC is equal to AC. Okay, so let's talk a little bit about what that is representing here. So I have a point B, and it's in between two other points A and C, all on the same line. Now the segment addition postulate says if I take these two smaller segments, so if I take the distance from A to B, and I add that to the distance from B to C, that is the same as the entire segment, the entire distance from A to C. So it allows me to put segments end to end, and I can combine their distances together, and I get the whole thing. So this is a postulate, and it's something we just accept as true, but it proves to be very useful in helping us work with segment lengths. So let's take a look at a couple examples where we do just that. So the first example, I want to find GH. So first thing, our segment addition postulate, what this would say about our diagram here is it would say if I take the length from F to G, and if I add that to the length from G to H, that should be the same as the entire length from F to H. So I go from F to G, and then from G to H. That's the same as going from the very first point all the way to the very last one. Okay, so this is our equation we're going to base this on. And now I can substitute in the values that they gave me. So from F to G, that has a length of 21. GH, this is the length that I want to find. And then the entire length from F all the way to H, this is 36. So this is the segment addition postulate, but as you can see here, this is going to work with subtraction as well. So I'm taking away a little bit of length from the entire length, and that's going to give me the length of GH. So 36 minus 21, GH has a length of 15 units. And if we go up to our diagram, that makes sense. So if it's 21 units to get from F to G, another 15 units to get from G to H, that does give us the same thing as 36 from F to H. All right, let's try one more example. And in this case, I want to work a little bit with some variables. So it says if AB is equal to 2x plus 1, BC is equal to 5x minus 3, and AC is equal to 40, I want to write and solve an equation for x. So I think the first thing we should do is represent this situation with a diagram. So I'm going to draw a line. And on this line, let's put a couple points. Now, I'm not sure exactly how long these segments are going to end up being, but this is just a representation. So based on the names, we have AB and then BC. So based on that, it looks like B is in the middle. And then we have A, and then our other point C. So this length from A to B is represented by the expression 2x plus 1. And then the length from B to C is represented by the expression 5x minus 3. And then the last bit of information we're given is that the entire length, so all the way from A to C, this entire thing is 40. So our segment addition postulate states that if I take these two smaller pieces, so the length from A to B, if I add that to the length from B to C, that's the same as the entire length from A to C. Again, that's the equation we want to work with. So now let's substitute in our given information. So from A to B, that is represented by 2x plus 1. From B to C, that is represented by 5x minus 3. And then our entire length from A to C is 40. And now written out like this, we have a regular equation. And to solve it, we just have to use a little bit of algebra. So on the left-hand side, let's combine our like terms together. 2x and 5x, that gives me 7x. 1 minus 3, that's going to be minus 2. And then this is still equal to 40. Adding 2 to both sides, we get 7x is equal to 42. And then lastly, dividing both sides by 7, we're going to get our value for x, which is 6. So just using the segment addition postulate, we're able to set up an equation where we can solve and find the value of x. Lastly, now that we know what x is, we can use that to figure out how long AB is and how long BC is. So let's finish up by doing that. AB, if we want to find the length, we just need to go back and substitute in the value for x that we found. So if AB was represented by 2x plus 1, we'll substitute in the 6. So AB is going to be 12 plus 1. So AB has a length of 13. In the last piece here, let's find out how long BC is. I could plug x back in. So 5 times 6 and then minus 3. 5 times 6 is 30. Subtract 3, so BC has a length of 27. And just checking our two lengths here, 13 and 27, if I add those together, we do get that entire length of 40 that we were looking for.